All right, this problem we're looking at is a quadratic application problem. So let's read it. A person standing close to the edge on top of a 96-foot building throws a ball vertically upward. The quadratic function h of t equals negative 16t squared plus 80t plus 96 models the ball's height above the ground h in feet, t seconds after it was thrown. What is the maximum height of the ball? Okay, and so the key word that we're looking for in this problem that tells us what to do is the word maximum. So if we think about what's happening, if a ball is thrown upward, it's eventually going to go back down. And what we're looking for is the height when the ball is at the top. And this is actually modeled by a quadratic function, and the graph is a parabola. So we're looking for this vertex at the top. Now, if we remember, our vertex formula for a parabola is the x value is going to be x equals negative b over 2a, okay? And I usually put that negative in the numerator so that the problem's a little bit easier to work. Now, let's identify our a, b, and c in this problem. So in this problem, our a is going to be equal to negative 16, our b is going to be equal to 80, and our c is 96. Now, the other thing I need to talk about with this problem is I'm talking about x's here, but we don't have x's in the problem, and that is because it's an application problem. So we need to think about what is representing x in this problem. And one way we can easily see that is if we look at h of t, and we compare that to what would normally be f of x. So h of t and f of x, okay? So our x is going to be represented by the t. And we can see that here. T is in seconds. And then our f, or our y value here, is going to be represented by the h, or the h for height here, okay? So if we're wanting to find the time, or the x value, we're trying to find the time, okay? So instead of x equals all this, I'm actually going to write t equals, because that's what it is in this problem. All right, now that we've kind of talked about variables, let's jump in and plug these things in. So here we have minus b, and again, b is 80 in this problem, over 2 times a is negative 16. So if we compute that, we have negative 80 divided by 2 times negative 16. That's going to give us 2.5. And again, we're looking at time, and it tells us our t is in seconds. So this is going to be 2.5 seconds. You can have this as a decimal, because it's an application problem. Now, if you wrote it as a fraction, that's not exactly wrong. It just might not be what the computer is looking for if you were using the online homework system. All right, now let's think about what the question was asking us. What is the maximum height of the ball? So our vertex, of course, normally has an x and a y. We just found the x value, or the time. But this is not asking for the time, it's asking for the height. So what we're really wanting to find is the y value here. And if you remember, maybe from previous problems or just working with graphing parabolas, the y value is, we get the y value by plugging in the t into the problem, or your x value into the function. Okay, so in this problem, we're going to go back and look at the original function. I'm just going to rewrite it here for our reference. Negative 16t squared plus 80t plus 96. And all we want to do here is take our maximum x value, or our vertex x value, 2.5, and plug it in to get our maximum y value, which is our height. Okay, so this is going to be negative 16 times 2.5 squared plus 80 times 2.5 plus 96. okay? Just be really careful plugging this into the calculator. You do want to have the negative 16, then the parentheses and the number, close off those parentheses and put the square. And when you do all of that, you get 196. And again, this is in feet, so this will be 196 feet. And that would be the answer we're looking for. So again, if it says height, you're looking for like that y value, the function value. So get that x value or the time, depending on the problem, plug it in to find the y value, and that's giving you that y value for the height.